So I feel like probably most people have heard this phrase microbiome. It has become a really fast-growing field. And what's interesting about the microbiome is if you look prior to 2000, there's almost no publications in the microbiome. And the reason for that is because DNA sequencing technologies are what's actually enabled us to create the entire field of microbiome science. And so you've seen this real exponential growth in the number of publications in the microbiome. And we now understand that the kind of traditionally in medicine, we think of these 11 different organ systems, but that the microbiome really represents a system that is tied to every single one of these 11 organ systems. And that has made it emerge as this really important biological, almost organ that we haven't really studied or understood well in medicine. Moreover, what we know now is that throughout our lives, our microbiome is under constant attack. And so there are things that we do that can cause our microbiome to become depleted. One of the most potent ways you can deplete your microbiome is through antibiotic treatment. So that essentially decimates your entire microbiome. Other things that have an impact on your microbiome are your diet. We know that as we age, our microbiome becomes depleted. We know that when we go through periods of intense stress, if anyone here has ever felt stress, that causes our microbiome to become depleted. We know when our circadian rhythm changes, when we travel, our microbiome becomes depleted. And we know that when we women go through menopause, our microbiome becomes depleted. So there are all these things that are just part of being a regular person that can cause your microbiome to become depleted. And the reason that depletion of the microbiome is relevant is because it is linked to a wide variety of different diseases, so all those organ systems that I was referring to. So we now realize that the microbiome is sort of getting us out of just the traditional place where we think about probiotics playing, which is GI issues, and into things like metabolic disorders, asthma, allergies, and even things that we've traditionally thought of as neurological disorders like autism and Parkinson's and Alzheimer's disease. Okay, so that's a lot of bad news. Our microbiomes are constantly being depleted. This leads to diseases. But in light of all of this, the light is that we can change our microbiomes and improve our health. And one of the seminal studies that showed us that there is this opportunity was initially done by Pete Turnbow when he was a postdoc at Harvard. He's currently now a professor at UCSF. What Dr. Turnbow did was he took the microbiome from this obese woman and put it into a thin mouse, and he saw that thin mouse become obese. He then took the microbiome from a thin woman, put it into an obese mouse, and that obese mouse became thin. And then he took the microbiome from this thin mouse that came from the thin woman and put it into the obese mouse that came from the obese woman, and that obese mouse became thin again. And the most interesting thing about this study is that these two women are identical twins. They are genetically exactly the same. The only thing that is changing their weight and their metabolism are these microbiome transplants. So that tells you there's something in this microbiome that is fundamentally changing their metabolism. And so how do you then start to figure out, well, what in that gamish is actually doing the work? And one of the fundamental things that we did at Pendulum and many other people do is you try to create a metabolic map of the microbiome. So I mentioned I'm a biochemist. I see everything in biochemical reactions. That's what you're seeing here. This is essentially your microbiome represented in a series of biochemical reactions. You can hone in on one, like carbohydrate metabolism, and you can understand what are all the different small molecules that are involved in the metabolism of carbohydrates. You can then hone in on, well, what are the strains that are involved in each of those enzymatic reactions? And then once you have that list of strains, you can hone in on a specific strain and grow it and study in the lab, and you can start to understand both its genomic capabilities as well as its growth characteristics. And so this is the fundamental data that underlies what is in our microbiome, who are the players, what are they potentially doing genetically, and then what are they doing in vitro, and starting to figure out how does this system actually interact with each other and how might you influence clinical outcomes.